Okay, this video tutorial looks at the mathematical strand of measurement and geometry, and more specifically, we're going to focus our understanding on our Pythagoras theorem, and also we're going to look at the converse of Pythagoras theorem. Okay, so what is Pythagoras theorem? Well, Pythagoras theorem is a way of solving problems involving right-angled triangles. So in a right-angled triangle, okay, the side opposite the right angle is known as the hypotenuse. So in our picture on the left, we've got our right angle. So the side opposite our right angle is known as the hypotenuse. All right, that's very important that you understand that. And essentially, Pythagorean theorem states that the length of the hypotenuse squared is equal to the sum of the length of the other two sides squared. So in this particular case, here's our formula, but A, which is one side, so A squared plus the other side, which is B squared, so the sum of the length of the other two sides squared, must be equal to the length of the hypotenuse squared. So A squared plus B squared equals C squared. Now we can rearrange this formula if you need to find a missing length that is not the hypotenuse. So let's say in our second example we're trying to find A, we would just rearrange the formula. So we would start with A squared plus B squared equals C squared, because that's our normal formula. But we want to find A squared, so therefore we would go A squared must equal C squared minus B squared. Okay, so if you're trying to find A squared or B squared, just minus the other side from C squared, and then you'll be able to work out your answer. So let's have a look at a few examples. In these examples, we've been asked to find the hypotenuse. All right. If the hypotenuse is not labelled, I want you to put an X next to it. Okay. So in our first example, the hypotenuse is labelled with an X. In our second example, it's not. So I'm going to put an X in. It says find the length. So the first thing I want to do is write down my formula. A squared plus B squared equals C squared. I know that I've got my triangle labeled A, B, and C. A and B doesn't matter, it's interchangeable, meaning that there isn't one specific side that has to be A, okay, just as long as C is the hypotenuse or the longest side. Now all I do is substitute my values in. 5 squared plus 12, whoops, not 12C, 12 squared equals X squared. 5 squared is 25. 12 squared is 144. That's going to equal X squared. Therefore, 169 is going to equal X squared. And to get rid of the X squared, I square root both sides. And my answer is 13. So X, therefore, is equal to 13 centimeters. In my next example, I labeled A, B, and C. So therefore, A squared plus B squared equals C squared. This becomes 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. Therefore 25 equals C squared. I'm then going to square root both sides. That's going to leave C by itself. That's going to give me an answer of 5. So therefore C equals 5 centimeters. Okay, so in these examples, we're looking at trying to find a missing length that isn't the hypotenuse. Okay, so I'm going to go ahead and mark those sides with an X. And this is where we talked about rearranging the formula. So if I want to put in my values, my A, B, and C, I'm going to label the triangle. I'm going to have A squared plus B squared equals C squared. But I want to rearrange it now because I'm trying to find the length of A. So this is going to become A squared equals C squared, take B squared. A is just X, so X squared, C squared, or C is 6, so 6 squared, take B is 3, so 3 squared. X squared therefore is going to be 36, take 9. 36 take 9 is actually 26, therefore X is going to equal the square root of 26 centimeters. Same thing over here. I've got A, B, C. So my original Pythagoras formula, a squared plus b squared equals c squared. I've now rearranged that, and it's going to be a squared equals c squared take b squared. I'm now going to put my values in. So x squared equals 10 squared take 8 squared. X squared equals 100 take 64. X squared equals 36. Therefore, x equals the square root of 36, and x equals 6 centimeters. Now, the other thing we were going to look at is the converse of Pythagoras theorem. So basically, the converse of Pythagoras theorem is just a way of checking if a triangle is right angled. So essentially, if you are given three sides of a triangle, or the lengths of three sides of a triangle, you can essentially check to see if it's right angled by substituting those values in. Now remember that the longest length is always going to be your hypotenuse. Okay, and the other two lengths are going to be your A value and your B value. And remember, this is your C value. So you simply put that in, which is essentially what they've done here. So they've worked out A squared and B squared, so A squared plus B squared gave 145. They've worked out that C squared is 144, so therefore it is not a right angled triangle because these two values are not the same. All right, and we're going to do some examples to show you that. Okay, so here are some examples using the converse of Pythagoras theorem to check if these triangles are right angled. So essentially what we need to do is we need to label these A, B and C. And we need to determine if A squared plus B squared is actually the same as C squared. So I'm going to work out my A squared and my B squared first. Okay, that's going to equal 6 squared plus 3 squared. So therefore, my A squared plus B squared is equal to 36 plus 9. Therefore, my A squared plus my B squared is equal to 45. Now, I need to work out my C squared and work out if that's exactly the same. C squared. My C squared is 10 squared. So my C squared is 100. And 100 does not equal 45. So therefore, this triangle is not right angled. Let's have a look at our second example. Okay, the square root of 3, it's actually longer than the square root of 2 and the square root of 1. So, if we try and work out our A squared and our B squared, this is essentially square root of 2 all squared plus 1 squared. Therefore, A squared plus B squared is equal to, well, the square root of 2 all squared is just 2, and the square root of 1 squared is just 1. So therefore, A squared plus B squared equals 2 plus 1, which is 3. Now I need to work out my C squared. C squared is actually the square root of 3 all squared. And the square root of 3 all squared is simply 3. And as this does equal that, then this triangle is right angled. And we've proven that using Pythagoras' theorem. Okay, I've now got some practice questions for you to have a go at. Please feel free to pause the video when the questions come up. When you think you've got them correct, continue the video and keep going working through the practice questions. Once you've finished them, the answers will come up and you'll be able to see how you went. Okay, so as stated, here are some practice questions for you to have a go at where you need to find the missing side lengths of the triangles. Once you think you've got them correct, continue the video and we'll see how you went. Okay, now here are some more practice questions where you need to use the converse of Pythagoras theorem to check whether these triangles are right angled triangles. Once you think you've got the right answer, continue on and we'll see how you went. Okay, so let's see how you went. In our first triangle, Alright, I'm going to label it A, B, and C. Remember, C is always opposite the right angled triangle, and C is called the hypotenuse. So in this particular case, we're trying to work out the hypotenuse. We can just use our normal Pythagoras equation, and we substitute our values in. We end up with 25 plus 16 equals C squared. Therefore, 41 equals C squared. Therefore, C equals the square root of 41 centimeters. In our second question, we're actually trying to work out not the hypotenuse, we're trying to work out a different side. So I'm going to label that A, that B, and that C. I normally would do A squared plus B squared equals C squared, but we're not trying to work out the hypotenuse, so I'm going to change it and go A squared equals C squared, take B squared. I want to substitute my values in. X squared equals 10 squared, take 9 squared. X squared therefore equals 100, take away 81. X squared equals 19. Therefore, X is going to equal the square root of 19 centimeters. Okay, now let's check your answers to the converse of Pythagoras. So here I'm going to label the triangle A, B, and C. I'm going to work out what A squared plus B squared is first. A squared plus B squared is equal to 9 squared plus 12 squared. Therefore, A squared plus B squared is equal to 81 plus 144. Therefore, A squared plus B squared is 225. Now my C squared is 15 squared. C squared therefore equals 225. This and this are the same. Yes. So it is, therefore the triangle is a right angled triangle. Well, yeah, I'll just put is right angled. Now the next one, let's check here. We've got the square root of 13, so that's going to be my C. Doesn't matter about A and B. Let's work out what A squared plus B squared is first. A squared is square root of 5 all squared plus square root of 8 all squared. Therefore, A squared plus B squared is simply 5 plus 8. Therefore, A squared plus B squared equals 13. Now I'm going to work out what my C squared is. Square root of 13 all squared. My C squared is 13. That is correct. Yes, and again, therefore, this is right angled.